the Energy Technology Center of the University for Development Studies under the School of Engineering. This is part of our monthly webinar series where we educate the public on energy efficient strategies and then the promotion of renewable energy. For this week, we are hosting Mr. Samuel Owusu, an officer at the Energy Commission in Tamale, and he's going to take us through the electrical wiring regulation LI 2008. The objective of this webinar is to educate the public, see the need or the reason to engage professionals when they are wiring their homes. The benefit for doing that is enormous. And as we go through this webinar, we'll get to know more and appreciate the need to engage professionals when we are wiring. I'm Engineer Mubarak Isaku. I'm the coordinator of the center, and we are bringing this webinar to you in collaboration with the Japanese Center at Nyampala, headed by Dr. Hamdia Alasan. So you are all welcome. Mr. Samuel, after his presentation, we'll have question and answer session for those who have questions to ask. And if it's within the scope, he will attempt them. And then if you want to have access to these slides after the presentation, please type your email address in the chat box so that I'll add you to our mailing list. The slides and then the recorded video will be on our YouTube channel. And currently, this webinar is also streamed on Facebook. Thank you for your time, and I hope you enjoy the webinar.
Okay, thank you, Engineer Mbark. So as Engineer Mbark rightly said, I'm an officer with the Energy Commission, and we've been invited to give a presentation on our electrical wire regulation. So, with no further ado, let me just delve into the presentation. I'll give a background of the Energy Commission and some technical units under the Energy Commission. For more often, people do hear about Energy Commission and they actually don't know what Energy Commission does. So this background will just enlighten all of us on what the Energy Commission does. And also we'll have a 7-minute video on the overview of the electrical wire regulation, which is the main discussion today. Then we'll move on to the electrical wiring standards. And then we'll now know what this electrical wiring regulation covers when it comes to electrical wiring. Then we'll have some cable standards we'll discuss, then fuse or MCBs, RCDs and RCDOs, the accessories. And after the wiring is done, what do we expect to see when it comes to the consumer unit labeling, when it comes to earthing, then inspection chambers. Then we'll move on to the Q&As. All right. So the Energy Commission. The Energy Commission is a regulatory body which is mandated by law to manage and develop the utilization of energy resources in Ghana. So what this means is we as engineers, or we as energy providers, energy producers, energy distributors, in as much as possible, if we want to transmit energy or power from one point to another, make sure that we are doing it efficiently. So the Energy Commission here is, as a regulator, as the name suggests, you're a fan regulator. You regulate it when there's heat to a very high degree, then you regulate it downwards to a degree when the room is a little bit cold. So a regulator does the same. You come out with schemes, you come out with some frameworks that would make power generation, power utilization in Ghana here very affordable and efficient. So that's what we do. So when you come to the Energy Commission, we have the Renewables and Energy Efficiency Directorate. They deal with the permits, giving people permits to deal with charcoal exportation. They also have officers at the port where they check the appliances. So you would remember, or you would notice that in town, we have some appliances that come with this star rating. And on these stars, you see from 1 to 5. It might be that 2 is highlighted, it might be that 3 is highlighted, or even 1. So the more the stars, the more efficient the appliances. At the moment, we are just dealing with, or we are certifying fridges, air conditions, and lamps. But we'll be extending this efficiency test to other appliances with time. Then we have the Planning and Policy Directorate. This directorate strictly deals with advising the ministry as to new energy developments. Like I said, day in, day out, as engineers, we are finding ways and means to come out with ways we could generate energy, which will be cost effective and also efficient without pollution. Then we have the electricity and natural gas. So the natural gas regulatory units, they also deal with regulating the natural gas sector. Anyone who endeavors into the natural gas production, the pipelines coming from Nigeria to Ghana, the pipelines moving through the country, there are some regulatory units that deal with all these regulations. Then my unit, the electrical regulation, the electricity regulation unit. Then you see the wiring there. So that is where I am. So I would say boldly that electrical wiring, it's the unit that has put the Energy Commission on the pedestal, that's put the Energy Commission across. So when people need power, you hear about Energy Commission. It's all about the electrical wiring. All right, so let's get an overview of the electrical wiring program. Then we'll take some little things we need to look out for when electrical wiring is done.
You are welcome to the electrical wiring program. This is an overview of the electrical wiring program so far. In this presentation, we will focus on purpose of the law, main provisions of the law, implementation guidelines, training of electricians, how to locate electricians, what landlords need to know, and then monitoring and inspection. Before 2012, there was no regulation to regulate conduct of electrical professionals in Ghana. The Parliament of Ghana passed the electrical wiring regulation LI 2008 in 2011 and it came into force in 2012. Now the law seeks to achieve two things: the safety of life and property. Safety of life from the risk of electric shock or electrocution, and then property from the risk of electric fire. The law focuses on three thematic areas, and I call them the who, the how, and the what. Who does the electrical wiring? How he or she does the electrical wiring? And what type of material he or she uses to do the electrical wiring? The Energy Commission of Ghana was given the mandate to implement the law. In the implementation of the law, the Energy Commission developed a guideline, and the guideline addresses the following: examination, certification, training, implementation, and monitoring. The following slides explain these. Examination. There are two forms of certification: the Certified Electrical Wiring Professional and the Certified Electrical Wiring Inspector. The Certified Electrical Wiring Professional is in three categories: domestic, commercial, and industrial. For domestic, it covers domestic houses or residential facilities with single-phase electrical supply. The commercial covers hospitals, schools, hotels, and malls. Industrial professionals and 154 certified electrical wiring inspectors. These are spread across the country. There are two forms of training for electricians: the pre-training and the post-training. The pre-training is organized by institutions recognized by the energy. A certified electrician next door. The next door electrician could be a certified electrician. All you need to do is to demand for his certification, and then you can also confirm his certification by using the Certified Electricians app. So what is the landlord expected to do? The landlord is expected to engage a certified electrician. The certified electrician, number one, will assess the job and produce an estimate. The certified electrician, when given the contract, will do the installation. After completion, the certified electrician would invite a certified electrical wiring inspector. The inspector, upon inspection and testing of the electrical installation done by the certified electrician, will now endorse the installation. This is done by appending his stamp and signature on the electrical completion certificates. The landlord submits the completed certificates to ECG or NETCO to initiate the service application process. Landlords who fail to engage the services of a certified electrician will go through a laborious service application process. Monitoring. The Energy Commission conducts periodic monitoring of electricians and utilities to check for compliance. Minor violations are referred to the disciplinary committee and an electrician could be penalized. Furthermore, all violations are referred to the law enforcement agencies. An electrician could be fined, jailed, or both. The law requires periodic inspection and testing of buildings. Every 3 to 5 years after 10 years of the initial installation, and finally, every 2 years after 30 years of service. In conclusion, you should use a CUWP because they are trained and regulated. They are mandated to use only approved electrical materials. They can be traced. You pay less and no wahala for service application. This brings us to the end of my presentation. Until we meet again, thank you.
Yeah, hello, you can continue. You are audible.
Nice. Okay. So that was a 7 minutes video. And my take from the video here was all these processes we are discussing here are legal processes. So what this means is you could face some jail time, you could face paying some huge amount of fines. Legal processes are not things to be joking about. There are things when you go against, you are likely to have a very severe process, and it's frustrating going to court up and down because of electrical works. Someone will say, how can that happen? But that's the reality on ground. Okay, so since now we are conversant with the processes involved in getting connected to the grid, we'll move on to some of the practices we do see on the field and we encourage electricians to do. And also, if an electrician is being engaged by you, a facility owner, we also want you to be vigilant when he's doing his work. Because more often, you are not technical people. Even if you are technical persons, it's likely your technicality doesn't extend to internal electrical wiring. So here is the case. Someone who has the know-how can do anything and just leave you wanting, but the law will catch up with them. So this is a simple diagram, which I believe everyone sees. There is one story here, and you could see the makeup of the house wire. So the 3 lines you see at the A point, you are seeing your line 1, line 2, line 3. And normally it's 4 lines that come to the house. So that means your phase 1, your phase 2, your phase 3, and you have your neutral. So once it enters the house, it goes to C. And the C there you see is a cutout. It's also a protective device, which gives protection to the energy meter that is being installed at D. So your energy meter is what will be doing the billing once you are doing your consumption. So once you are buying power and your loads are consuming electricity or is consuming power, the energy meter will be there reading just to give you a fair idea about what power you are consuming at some point in time. Then it moves on to the E, which is normally we term it a main switch, which is another protection. It's also protecting the main installation, the main electrical installation in the house. So you are seeing E and F. F could be an RCD, which we'll get to shortly. Then you see the G side. There are also sub-circuit breakers. So you see, we call them MCB. It can either be a breaker or a fuse, which we'll be looking at shortly. So this is generally how an electrical installation is. where the grid feeds the power into the house, it goes into a cutout, then to a meter. But lately, this is the new developments. ECG and NETCO, which are our main power distributors or utility in Ghana here, due to some reasons like power theft, they've derived some means of installing their meters on poles. So in this case, coming from, that's your LV lines, your phase 1, phase 2, phase 3. They don't pass through the cutouts. They don't pass through the cutouts before going to the meter. It passes through the meter, then now goes to the cutout. There's already protection in the meter. That is how come they are able to do it this way around. So when it happens this way and you are using the power, then we term it, now you are on the grid. And everything here has to conform with certain standards. It has to have certain protection before the connection is done. Once those things are not met, then you are breaching the electrical wire regulation, which the Energy Commission and everyone wouldn't be happy with. All right. So now we move to the cables. This has been, I wouldn't say a challenge, but something that people keep visiting, which we keep drawing their attention to. You know, when a regulation or a law comes to be, people need reasons to obey the law. They need valid reasons why you are bringing something up. When it comes to the use of cables, what we realize is people do like the inferior ones. When I use the word like, it's because the inferior one is cheap. And you know how cheap things are. It doesn't go through the quality analysis process. But we are saying for a house or a facility to meet the minimum standard of wiring, then you have to use approved cables. And these cables must be approved by the Ghana Standard Authority. There are certain cables in the system which are standard, but once it's not approved by Ghana Standard Authorities, you and I can determine, or you and I can say that cable is eligible to be used for wiring. So Ghana Standard Authorities has done the public a favor, and all the approved cables used for internal house wiring have been placed on their website. So you see the service.gsa.gov.gh. This website gives you access to Ghana Standard Authorities cable list. And these are some honorable mentions: Havels, Tropical, Nexan cables, Leroy, etc. There are a lot of approved cables around. The other ones in the system, which we are saying are not approved and are substandard, are the ones we don't encourage electricians to engage in using for wiring, or we don't encourage customers to go and buy them and use them for wiring. So for a simple test, once an electrician comes to you and you've given him or he has given you your bill of quantity, what a bill of quantity is normally what we call the estimate. He gives you that and you see cable there. So whatever cable he lists there, or he has listed there, you need to go to the Ghana Standard Authority just as a verification check. Then you input the cable name there. Once it is approved by Ghana Standard Authority, the cable will pop up. If it doesn't pop up, then you know that this cable hasn't been approved. So you don't go near the cable at all in the first place. Even though they are approved cables, we know people do synthetic ones. Synthetic in the sense that they do refurbish. So once you are refabricating the original cables, then there is another way as a layperson to determine whether this cable is original or not, by the use of a magnet. Just get a magnet. And they are saying for internal house wiring, pure copper or copper alloy. The copper alloy in the sense that the copper percentage has to be about 90 or at least an 85. That is more of copper. 90 will be appropriate. So if you get a cable which has this pure copper quantity and you use a magnet to attract this, or use a magnet closer to this cable, you realize that the copper wouldn't attract magnet. It's basic science. Copper doesn't get attracted to magnet. But for other metals which are not the standard materials for cables used for house wiring, when you use the magnet, you find out that they are attracting readily. So those cables, you just don't go near them when you are engaging an electrician to do the wiring. One may ask, but why are these cables still in the system? Yes, people have their way of bringing cables into the system, which very soon the Energy Commission will also come out with an LI to check dealers who deal in cables and accessories. That's from periodically, like how we go for our monitoring. We'll be visiting these dealers and we'll be checking what cable stocks do they have. There will be a template for which we'll be reporting all their cables. So once we go and see a cable which is not on a template, then you have some questions to answer. It's a gradual process, but we can also tackle it from this aspect, where we'll be advising and keep on speaking to customers that once you see this cable, these are the procedures you can use to verify whether this cable is a good cable or not, in your own small way. Because if the cables be the cause for your house to get bent, you realize your whole years of investment has come to nothing. It's very, very sad. All right. So another device or another element we use in electrical wiring are the fuses. And this fuse here is a rewirable fuse. So this fuse, it consists of a fuse base and a fuse carrier. And we have a fuse melting element. And these fuse melting elements are thin copper. They are designed in such a way that when it's subjected to a certain current, this fuse or this thin copper or lead or aluminum will melt, and we say the fuse has blown. When it happens that way, then we would have to rewire the fuse. That means we have to find an equally yoked gauge, an equal gauge. So if the gauge of the wire, the melting element, were to be, let's say 0.5 millimeter square, you have to find another 0.5 millimeter square of the same fuse element. Then you rewire the fuse. You know, it's quite technical. So once it's been installed by an electrician, even some electricians don't have the technical know-how to gauge the wires and rewire the fuse when it gets blown. Another question too is, what will make a fuse get blown? There are a lot of instances that you can get a fuse blown when the current passing through the fuse is above its rated current. So we can have a 5 amp fuse. So when you have about 6 amps passing through the fuse for a number of milliseconds or seconds, then you realize the fuse will get blown. These are all protective devices to protect the circuits in the system. They are to protect your devices in the system, your appliances, which is in the electrical system. So with that shortcomings, then we had to improvise as engineers. Then engineers came out with the miniature circuit breaker. So this is a miniature circuit breaker, which when splitted into two, you see it at the right-hand side. It's quite a complex device, but the work this does is quite important. And more often, the Energy Commission and most electricians, we advise them that you should be adding miniature circuit breakers to your estimate or bill of quantity rather than fuses. And you'll see shortly why this is so. So this is how the miniature circuit breaker works. It works or it trips on two disturbances when there's a short circuit and when there's an overload current. So when we talk about overload current, it means the current that is passing through or the current that is in the circuits in which this miniature circuit breaker or MCB is protecting has gone above the rated current. So, for example, we have a 6 amp miniature circuit breaker, and this 6 amp miniature circuit breaker is supposed to operate when the current has surpassed the 6 amps. So let's say a current of 7 amps or 8 amps is flowing through this miniature circuit breaker for a certain number of period, for a certain period, let's say so for some milliseconds. Then this miniature circuit breaker would have to operate. So you see the bimetallic at the right-hand side, where the cross-section of the miniature circuit breaker is written, there's a bimetallic stripe there. So when this current, which is over the rated current, passes through the MCB, it then hits it up, then causes it to bend. Then once it bends, there's this latching point there, and it also trips or it activates this operating mechanism. Then the operating mechanism is connected to this fixed contact, and this fixed contact responds. So it all starts with a bimetallic for overload currents. Once it gets heated, it then bends, initiates the process for it to trip. And once it trips, and what will cause an overload current? The engineers on the platform here will bear this. There's something we call voltage surges, voltage dips, voltage fluctuations. They are all power system disturbances. They can all cause this miniature circuit breaker to trip. So when you have a surge in the voltage, then you realize that once the voltage has increased, then you are likely to have an increase in current. So if that happens, it can happen for just a short period. So once it trips and you go and trip it back, and the fault has been rectified by sometimes the distribution company who is supplying the voltage, or sometimes too from your load side. If all these things are rectified, then you can trip it back to a non-state. So you realize you don't need a technical know-how to operate the MCB. It's just a trip mechanism, which you go up and down. But we don't advise customers or facility owner to just go and trip their MCBs, because some faults might exist past the MCB. But regardless, if an MCB trips, it's likely if the fault persists, it's likely if the fault persists, the MCB, when you trip it will trip back again, showing that the fault still persists. The second mechanism the MCB operates is on short circuit. A short circuit is simply saying your live and your neutral has merged. So if your live and your neutral in the electrical installation merges, we call it a short circuit. And this thing, when it happens, it generates a high current. So this fault current causes the MCB to also trip. So there's some electromagnetic mechanism also in the MCB. So you see one device is operating under two fault conditions, overload and short circuit. So that's the advantage this MCB has over the fuse. You can trip it easily when the fault is being cleared. You don't need any technical know-how to go and rewire the fuse again. So let's move straight on
to. Yes, all right. So what we see on the screen now is an RCD, and its full name is a residual current device. And we have various forms of RCDs in the system now. We have the one which is just close to the sockets, or even some RCDs are infused in the sockets now. But we are saying at least if you're unable to get for individual circuits, get an RCD that would protect the whole facility. So the device you are seeing there, an RCD, we kind of term it as the holy grail of electrical wiring now. It's a very important device, very, very important. That it's quite mandated. We'll get to a portion of the law where the requirements to install an RCD will come in. And we'll all realize that we have no option than to include the installation of an RCD, just like you adding a cable to doing your electrical wiring. It's a must, we need them, and it's a life-saving device. So what's so important about this RCD? But first of all, let's take the operating mechanism. So on your right side, you are seeing 3 coils. We see a primary coil, we see a secondary coil, and we see another coil there, which is the sensing coil. So what this means is we are connecting our life. That's what is carrying the electricity, or what's carrying the power from the distributor to the facility when it passes through the RCD. We are connecting the live part to the, we are discussing the internal structure of the RCD now. So we are connecting the live part to the primary core. Then now the neutral part is also connected to the secondary core. So in electricals, there is something we call a return current. Once your current comes to the facility, the current doesn't stay there. It has to return to the supplier again, the supplier's transformer. So the neutral cable is what returns the current back to the supply transformer. So what this RCD does is comparing the currents here. And if the live current is flowing through the RCD to the device or to your appliance, it creates something we call a magnetic field, electromagnetic field. And this electromagnetic field is being compared to the one that is coming out from the neutral side through the secondary core. So another electromagnetic field is being created. So the comparison here is, if one electromagnetic field is created above or is generated above the other, and more often it happens to occur when it's coming from the neutral. So that means the magnitude of current that was entering the device, the RCD, to the appliance is not the same, or it's not similar to the magnitude of current that was coming out. And we know once there's power flowing, there will be some losses. But this RCD is designed such that the losses shouldn't exceed a certain degree. It varies from RCDs to RCDs. So if, let's for example, if 5 amps is passing through the life and goes and creates a magnetic field at the primary core, we should be expecting, ideally, that 5 amps will also be passing back through the secondary core, through your neutral. But we won't get it that way. But we are saying there should be some tolerance, a minus or plus. So the RCD is weighing these options. Okay, fine. The 5 is coming, but it's not 5 is coming, but there should be about 4.99 or 4.98, or even exactly 5. So when it deviates over the rated capacity of this RCD, let's say about 2 amps is gone, 5 is coming from the life, and 2 amps, and let's say 3 is coming back through the neutral. So that means 2 amps is missing. Where is it? This is where it becomes critical. That 2 amps might be hovering around an appliance, or that 2 amps might be going to the ground, or that 2 amps might be passing through a human body. So once the RCD senses that the 2 amps is being deficient in that 5, then it trips. So that means it's going to also induce another current inside the 3rd coil, which is the sensing coil. Then it trips the relay. So you see down there, it's saying that the toroidal transformer, sensing coil and relay together, is known as the RCD. It's just these components that make up the RCD. So simply put, the RCD is comparing the current in the live and in the neutral. If there are some deficits which is greater than the rated or stated capacity of the RCD, then it trips. Given the fact that, one, when you do wiring, there are faults in the system. There can't be faults in the system. And when these faults arises, there should be some protection. There should be some mechanisms that will make these faults not persist to another circuit or not persist to a human being. And what we know here is current wants the least resistive path to pass. So for instance, you have a faulty appliance, let's say a fridge. And it happens that the live part of the fridge where the live current pass is touching the metallic body of the fridge. When you have an RCD in place, the RCD will realize that this fridge is taking power or is taking current to a place where it's not supposed to take it, because it will return the exact current back to the neutral. Then it will have to trip. Wouldn't we be happy when such a device is in the facility? Yes, we've been getting issues about the use of RCD, that it has this nuisance stripping. And this is as a result of people they are not using the appropriate rated RCDs for the particular facilities. And secondly, too, it might be there is a fault that needs to be corrected. If that fault is not corrected, the RCD will never stand still. It will trip, indicating there is a fault. So once that fault is corrected, the RCD will stand still. So that is the holy grail of electricity now, an RCD. And we have further devices that are even more advanced than the RCD, or let's say it's a combination of the RCD and other devices. So we know now that RCD doesn't trip on short circuits, it's the MCB that does. So people will be asking again, then why don't we just buy MCBs? So MCB does the same function of the RCD. That is not true. The MCB will trip on overload or overcurrent. Then the MCB also trip over short circuit. Then the RCD here is combining the neutral and is comparing the neutral and the live current. It sees some deficiency in them, then it trips. So the RCD is tripping on residual currents. Then that residual current is very harmful, very, very harmful. It could cause you a lot of bills when you are buying power into the ground. This RCD can detect all that. And in cases of even fire, the high range RCDs, about 500 milliamps RCDs and things, do also prevent some fire outbreaks. It detects when there's a fire about to happen in the circuit it's being connected to. Then it trips the circuit off, cuts power from entering that circuit. All right, can we move to the next slide? Okay, so like I was saying, the benefits of RCDs or RCCDs, they are all the same devices. That is the safest way to detect and trip against electrical leakage currents, which I already went through. And there is some survey there that only 70% of the public know what an RCD is. And I can now boldly hit my chest and say, now 80% of the public know what an RCD is, because after this series here, I know we'll all go and spread the news about what RCD is, and we'll reach that 80% mark. Okay, can move to the next slide. Now, accessories and appliances. So just a recap, we are just looking at the components that make up an electrical installation. First, we started with the cables. Now we've gone to the protection, where we saw the fuse, where we saw MCBs. And now we saw the RCDs. Then now we are coming to the accessories. Now, after you've installed all those things, now we come to the accessories. What type of accessory are you supposed to buy? What kind are you supposed to buy? The Energy Commission has also come out with these star ratings. And these star ratings determine whether an appliance is efficient or not. In my initial submission, I was saying, in as much as possible, we are generating power. We want to generate power effectively and efficiently. In the same vein, when we are using power, we need not to use power anyhow. We would like to use power efficiently, because it's money we are using to purchase this, money we are using to generate this. So you see the air conditions there, there are these star ratings there. So the 3 stars here, that shows that this fridge is efficient, but not up to the 5. So a lower star, let's say 2 stars, is also going to show that the fridge is efficient, but not more than the 3 star. So you could have a certain particular brand of fridge or air conditioning, the same brand, the same model, but one will be a 3 star, one will be a 2 star, another can be a 1 star. This is because of the efficiency of that fridge or air conditioning. Then you come to our LED bulbs. We also advocate that now there are developments. The onion type of bulbs, we don't use them in the system anymore because we've realized they are not efficient. So the LED bulbs, they are the okay. Now, after the installation is done, these are some of the things that would advise customers, would advise facility owners to look out for. And we also advise electricians when we have our training sessions with them that anytime you do wiring and you are done with the wiring, the final circuit is done. On the distribution board, the consumer unit, you label them. So when you look carefully, you see some yellow stickers with black writings on them for each and every breaker, indicating what a breaker is controlling. So coming to the right side, you could see the main lights, you could see the smoke alarm, you could see storeroom skits, then so on. Why do we do that? Someone might ask, why do we do labeling? Is it not a waste of time? No, it's not. Like I'm saying, more often, we who have our facilities, we are not technical people. Not all of us are technical persons. So when the electrician or inspector are done with their work and they go to their various homes or destinations, it's now left with us and the electricity and the installation they've done. An installation can be perfect for a while, but things do happen. There are external things that can cause disturbances to the installation. So when these disturbances come, what is in place for you to curb this disturbance or eliminate it entirely? So now when you label a circuit, this is what happens. If there is a fault in the socket outlets in the kitchen, once you detect the socket outlets in the kitchen, as soon as possible, you can go and isolate that fault without affecting the other circuits. You don't have to go and switch off or trip the main breaker, which will cut power source to the entire house. You just have to isolate the portion that is faulty. This is what we call discrimination in electrical wiring or electrical engineering. You are making sure that a certain portion which is faulty, the protective mechanism at that portion trips. It trips or it protects that portion without affecting other circuits. So that's the main reason. One reason we do the labeling. And also, in times where you have to do inspection and testing, it's very easy when you are doing inspection and testing when the circuits are labeled. Because you know you are working on these circuits. Whatever issue that arises, you know the particular circuits you are working on. But when it's not labeled, you will now be doing your try and luck. You go from circuit 1, you go from circuit 2. For all you know, the problem is on circuit 10. And all the time you waste on all the circuits before you get to 10, labeling can cut those things short. The next slide. Yes, so like I said, easy identification and isolation of faulty circuits, and it aids in doing electrical installation, inspection, and testing efficiently. Then we move to earthing. So now that the electrician is done installing all the necessary protection, he has installed his MCB, he has installed his RCB, he has done his labeling. There is an important aspect of electrical wiring, which we also don't joke about with. When Energy Commission goes on their monitoring and they come across a facility which doesn't have an earthing system installed, that is a very, very big felony. I'll use the word felony because you don't like the customer you've done wiring for. You would want, I wouldn't say you are wishing him well, bad, but you doing that is similar to leaving the customer to his fate. of electricity, the rat of electricity. Why do we have to employ earthing? So this is a simple way to know that an electrician has installed an earthing system. We normally, on our trainings, we always advise them to use the correct cable sizing and the correct cable colors. So your green and your yellow is the color denoted for an earthing cable, be it a 1.5 from the lightning or a 2.5 from the socket. Wherever there is earthing, it should be a green and yellow cable. So what does the earthing do? So the earthing is known as the process of transferring the immediate charge of the electric flow directly to the earth ground, such that no current carrying part of the system rises to a potential beyond its normal value. Okay, what does this mean also? Let's go back to the analogy of the fridge. You have a fridge which has been working for so many years, and the fridge, you realize when you go closer to the fridge or you touch the fridge, at some instances, you get this quick or sharp shock. Yes, I think almost all of us through our lifetime have experienced that before. This is where earthing plays a very key role. And at the end, you realize the earthing and the RCD, they move hand in hand. So what role would the earthing play? When you are experiencing such a shock from these fridges, it's an indication that there might be a leakage in the fridge. And these leakages, we don't expect these leakages to remain in the fridge. Not in the fridge, not around the fridge, not the metallic body of the fridge. No, it's very little when someone touches this, or it extend to a point where the current now, which is leaking, is very high. And if you touch the fridge, you could get electrocuted. So when an earthing system is installed, what this does is, please the next slide. What this does is, it picks this leakage current. We call it earth fault. It could be that the live part in the fridge, the one carrying the live current, is touching the metallic body, or it could be the neutral part is touching the metallic body. This is the reason why the neutral part too can cause that. You know, neutral returns current back to the distributor transformer. But when it's returning the current and it's touching the metallic body of an appliance, an earth fault can also occur. So it's not just the live part, the neutral can also cause that. So the system you see there is a portable house. Then you see some rods in the ground. So if we all have observed electricians working, and those who are going by the standard which we advise them to, you see that at some point in time, they go behind the house or beside the house and dig. They dig about 4 to 5 feet or even more. And then they require you in your estimate or bill of quantity to provide a rod, which I know more often as customers, we don't want to investigate what will you be using that for, what is that, why are you buying this and all that. It's a normal thing. You know, electricians buy that. So when they're asking money to go and buy that, you don't ask for that. So this is the reason why they are doing that. So they plant the rod into the ground, then they get the cable I'm talking about, the earth cable, and connect the whole house. The whole house. When I'm talking about the whole house, I'm talking about the non-current carrying parts, the non-current carrying conductor of appliances to the ground. So you see this green and yellow cable in your sockets. You see them sometimes in your lightning system, where you put your lamps. You see them sometimes in the AC circuits. So this cable is supposed to carry this leakage current through to the ground through that earth electrode, the rod the electricians plant in the ground, so that to prevent shock. And also when it comes to the lighting system, as in the lighting and thunder, it also does the same. It directs those lightning through the lightning arresters to the ground. So earthing system plays a very key role in electrical installation, which you can't isolate. It has to be part, just like the RCDs. It must be part of this installation. You can't do, or you are not supposed to do, electrical wiring and earthing system is not provided. The earthing system has to be provided. So this is what we as facility owners should be looking out for. The electrician says he's done with his work. These are the questions you ask him. Did you provide earthing? Show me where the earthing is. Is it green and yellow cable? If not, you question him. Why is it not green and yellow? Maybe he might have a clear explanation to that. If the explanation doesn't make sense, so the right channels you could pass to get the right information. Engineer, next slide. Once you have a facility and you've provided your earthing system, you will have to run a test to confirm whether the earth is effective. So how do we know that the earthing system is effective? We have to conduct a test called the earth resistance test. And there's an instrument called the earth resistance tester, which we use to test, or we use to get a certain value to confirm that the earth resistance is of a standard. The standard resistance we permit is a 0 ohm and below. You have to get 0 ohm and below. But technically, and the engineers on the platform here, you would bear with me that it's very difficult to get 0 ohm when it comes to earth resistance. So what then can you do? So we've had another provision again that if your earth resistance is not the 0 and below ohm, and it starts from 1 to a 50, then you can maintain the earth, but you have to add an RCD. So this is what it means. You've done your earthing system. The electrician is done. He calls the inspector to come over, or the electrician himself tests the earth to see whether the resistance is of the standard. And after doing the test, he realizes that the resistance is way, way, way above the standard. Let's say 100 ohms, which is very bad. 100 ohms for earth resistance is very, very bad. This is the reason. Like I said earlier, that current needs a less resistive path to flow. So if your resistance to the ground is 100 ohms, when there's a fault current, the resistance to that fault current going into the ground will be very high. So let's give this scenario here. Someone is touching a faulty fridge where the current is, but that current is supposed to go into the ground. So if the person's body is about 5 ohms and the ground is 100 ohms, where do you think the current will pass? It will readily pass through the 5 ohms. But when you have a very low resistance to the ground, it will rather go there than the human being who has that low ohms. So comparing the 5 to a 0, which will be effective? The ground. So the fault current or the earth fault current would go through to the ground. So this provision is saying, if you are unable to get the 1 to 50 ohms and it's 100 ohms, you have to improve your earthing system. And the electricians have this know-how to improve the earthing system. They get earth enhancing materials where they have to pour in the pit there. So you see the open concrete you are seeing there, in order to improve the earth to the range 1 to 50, then you install your RCD. So the RCD moves hand in hand with the earthing system. So if you have this kind of protections on your facility, things about electrical shock or your appliance getting damaged due to heating, which is not from the cable, would be very minimal. It's likely not to occur when there's an RCD and an earthing system. If done properly, yes, you are likely to not get these shocks. Can I move to the next slide? The next slide, please. Okay. So, electrical practitioners who aren't from this generation, they would confirm to this that initially the service cable, that's the cable from the distributor to the facility. So, like we started earlier, you connect from the pole. I'm talking in the layman terms. You connect from the pole to the house. That's your cutout. It used to be 10 millimeter square. That was the practice that they were doing. But with time, it had to change from the 10 millimeter to another wire gauge, which will go there shortly. So the 10 millimeter for service cable is no more in use. So this is where I'm saying another questioning can be done when an electrician is working on your facility. What cable sizing are you using from the service to my meter, to my cutout, to my distribution board? All should be a 60 millimeter square, not a 10 millimeter square. 10 millimeter square is no more in the system. We would shortly know why we are not using the 10 millimeter square again. Consumer unit. You realize that most facilities, when you go, they have not labeled their consumer unit. We see more of them in the system. So we call the electricians to book when we come for our monitoring. And our inspectors are doing very, very well. The inspectors we certify. They are doing very, very well to check all these things. Now, when they go to the facilities and they see that the electrician has wired the facility and has not labeled the consumer unit, this socket, what breaker is controlling that socket? This circuit, what breaker is controlling this circuit? It all has to be written on it, just like we saw initially on the picture, the consumer unit we saw. If it's a first breaker, some simple inscriptions can be done there. If it's controlling the AC, then you write AC there. If it's controlling fan and lightning, let's write fan and lightning in hall. Another breaker controlling fan and lightning in the dining hall and corridor. Depending on how the wiring has been done, then you label accordingly. So please check out for this when the electrician is done wiring. It will save you a lot. I already went through the reasons why these things are done. Then the use of rewireable fuse, that's circuit protection. A fuse isn't a bad protective element, but there's a better protection than that. There's a better protection than the fuse, which is the MCB. So using a fuse, yes, of course, when there's a fault, it responds and blows out. But once it blows out, you have to wait for a professional person to come and rewire the fuse, or you have to buy a new fuse altogether, which is quite tiring. But the MCB doesn't present that to you. The MCB can be there for as long as the fault persists. It will trip, but once it's cleared, then that is it. You can trip your MCB back and enjoy your power. Then half conduit wiring. We'll pull up a picture very soon. Then you would appreciate what the half conduit wiring is. So those who are privy to an electrician working on their facility, you realize after the electrician has done chiseling the wall or using a cutter on the wall, they place a PVC pipe in it. Yes, that PVC pipe. Those PVC pipes are supposed to house your cables. They're not supposed to run bare in the wall. They're not supposed to run bare on the ceiling. So an electrician will do a wiring and the PVC pipe would run in the wall, okay. But when it gets to the ceiling, where the wooden structure is, then he leaves it bare to run on it. It's against our standard. It's not supposed to be done. If you engage an electrician's services and he's doing that, you can draw our attention, or you can stop him from working. It's your facility. If anything goes out, it's likely you can't get him back because you had to comply, or you were in line with him doing the work. So once you stopped him from doing that, then you get to know what you are saying half conduit wiring is. You don't have to do the half conduit again. You have to do full conduit. Then a 10 millimeter square or less for earth electrode conductor cable. That is also out of the system. You ask the electrician, what cable gauge are you using for my earthing conductor cable? And once he says 16, then you are good to go, because you've confirmed that he's using 16. Then the use of old cable color code. Okay, so this varies from country to country. When you go to the US, they might be using the red, black, then green and yellow for your earth. But when you come to Ghana, it's different here. We also have our standard. We are no more using this red, black, green, and yellow. We are using the brown, blue, and green and yellow. That's for single phases. Then the old wiring practice, they weren't using RCD. Electricians weren't using RCDs, which now you and I can confirm that the RCD is a must device to be installed in an electrical installation or an electrical wiring. And then they weren't creating an inspection chamber. It was very difficult to get access to the earth rod once you've buried it, because they cover it with sand. They cover it entirely with sand. So how would you be able to confirm that the electrician has even buried a rod in the ground and has connected the cable to the rod? That is the main reason for the inspection chamber. The chamber we just saw, that we have to confirm that there's a cable running from the facility to the ground and it's connected to the rod. We can see it and we will be able to test it in future. So let's move to the next slide. What then are the new wiring practices? What then are the new wiring practices? So now we see 16 mm for service connection cable instead of the 10 that was being used. The reason being now is, since we are advocating for 16 millimeter square for your earth cable, like we are saying, if you want current to go readily through a conductor, then there's a relation between the conductor diameter and the resistance. The larger the resistance, or let's say the larger the conductor size, or the bigger the conductor size, that is when the low resistance the conductor is, or the lesser the conductor is is resistant. So let's compare 10 millimeter square to a 60 millimeter. A 10 millimeter will have a very high resistance as compared to 60 millimeter square. It's all captured in the Ohm's law, where you have your relation of your voltage to your current and resistance. So once resistance is high, then you'll be needing a very what? Or let's say once the conductor is bigger, you'll be needing you'll be getting a very low resistance. Once the conductor is smaller, you will be getting a very high resistance. And we don't want that for our earthing system. We don't want that for our earthing system. We always want a very low resistance so that earth fault currents can go readily into the ground. So your 16 for a service cable, once 16 is coming into the facility, if there's a fault, 16 should also transmit it to the ground. That's the analogy here. Then for some facilities, they do upgrade. So when you go and use a 10 millimeter square cable, at some point in time, the facility owner will be using a television and just a fridge. But as his salary has been increased and things are going on for him, there is an appetite to also increase his standard of living. He goes to get an AC. Then he gets other stuff in the facility, a water heater, gets a cooker unit. So all these things are drawing more load. And your cable's current capacity should match the load, or the cable that is bringing power into your system should be able to match the loads being used in the facility. So a system will cater for all those things. because 16 readily allows these currents to pass through, but the 10 won't. So once the currents being drawn from these loads are very high, it puts burden on this, burden us in stress on this cable, which is 10 millimeters square, rather than the 16, which will be able to handle it perfectly. Then the use of MCB as circuit protection. We've already gone through the benefits of MCBs over the fuses. Then the consumer unit labeling, very important. So these are the new practices. Then full conduit. Please, can we go to the next slide so that we see the full conduit wiring? Good. So I guess some of us here are saying, wow, the electrician didn't do you good, because maybe you are handling a facility at the moment and you don't have these pipes on the ceiling like this. It's not too late. You can still let him go back and rectify it. Or if not, you could get another professional to rectify this. And you know from the video, you are not supposed to engage someone who is not professional. Because those who are professionals, you keep bringing this thing in their head. You keep bringing it to them, you keep prompting them that there is no half conduit again. And with time, it's going off the system. All we realize is the non-professionals are the ones doing the half conduit. When you engage a certified electrician and he does half conduit for you, we'll catch up with him because we'll come on the field to do the monitoring. Our certified inspectors will also catch up with him, because after he's done with the wiring, they invite the inspector to come and confirm this, and he wouldn't certify the facility. So this is a full conduit. Why do we do full conduit? Over the years, we realized that when the cable is running bare on your ceiling, the risk of fire outbreak happening in the facility as a result of cable burning on top there is very high. Because you would agree with me, some people after building like this, they'll put their T&J there. And when you put a T&J there and a cable is running bare on it, and what they do normally too is they secure the cables with nails. And with time, when you use the cable round the nail just to let the cable be firm, you are causing something we call inductance, because the cable is also a conductor. You are causing inductance. And once the cable is not meant to act as an inductor, then you cause some heating in the cable at that point where you've rounded the cable over the nail. Then this can lead to the cable heating, and heating moves to your melting. The melting will then lead to the almighty fire. And when it catches the T&J, the facility is a damn deal. So when it's concealed in a pipe like this, just like in the wall, all the protection it gets when it's in the wall, that's the same thing the cables get. Adverse weather conditions don't affect the cable that much. It's being concealed. Even when there is a fire, before it gets and burns the pipe, then maybe the fault might be rectified quickly. Moreover, there are rodents, rats, mice, who enjoy chewing certain cables very much, because they also find their daily bread from such things. So if you have your cable lying there and these rodents get in touch with them, the same thing, they can chew off some portions, weaken the insulation. The insulation is the rubber part of the cable. They weaken the insulation of maybe a couple of cables running together. It causes these short circuits, also creates sparks, and then the almighty fire sets in again. So at any point in time, you don't have to compromise on this. Remember, you paid money for blocks, you paid money for the woods there, you are paying for the electrician's service. So why don't you let him do the right thing than he advising you to do the wrong thing? This is both ways. The electricians also complain that customers are being difficult. They don't want to release the funds to do this proper wiring. Customers are also complaining. The electrician didn't enlighten me on this. The electrician took money for that, but didn't provide that. All these things, now we can be certain that when an electrician is coming to your facility and he's going overboard, you'll be able to determine. These are just basics. They are the basic things that when you get right on a facility, it's likely you experience fire outbreaks. So that's the full conduit. Please, can we go back? Okay, so the installation of RCD, always, it's written there, always install RCD, always. Because today you might get a good earth resistance value, but tomorrow it might be bad. The RCD will compensate for that. So once you know the uses of RCD, you know the benefits of RCD, why not buy it in the first place? Let the electrician include it in the estimate. Once he gives you an estimate, you look out for these things. Electrician, have you purchased, did you make provision for RCD? He says no, you question him. Have you made provision for MCBs? He says yes. That's nice. You confirm with that. Make provision for the 16 millimeter square earth cable. No. Why? Question him. You see, be a watch too. Don't just release monies for someone to work and that is it. It might bring issues later. Even though when the issues arise, we the Energy Commission will come to the aid. That's fine. It's an electrician, certified electrician who did the wiring, and he can be traced and prosecuted for losses. But yes, still, you know some of the electrician's condition. Would they be able to recover all those damages in your 3-bedroom apartment? No. So you let them do the right thing in the first place. All right, move to the next slide. Yes. So the last point was to purchase a fire extinguisher. Another very important thing we sometimes overlook until there's an issue. When you purchase a fire extinguisher, it saves you a lot. In as much as we are advocating for you to use protective devices and use the right materials for wiring and all that, like I said, there are adverse conditions that can affect your wiring, which might not be as a result or as a fault of the electrical installation, but it might be as a fault of the use of certain appliances, these second-hand appliances. So when that happens and there's an event of fire, your fire extinguisher should be readily available. And these fire extinguishers, which are readily available, would solve this problem. So you get a powder. This powder fire extinguishers are extinguishers used for electrical fires. There are classes of fire extinguishers. But if you get a powder one, just like this, which has an element sulfur fluoride, you'll be able to tackle the electrical fires. You don't use water to quench them. Because the water we have around, they are not all that pure. So they are conductors. So when you get the powder one, it could save you a lot from letting the fire escalate. So the new and the old color codings I was talking about, you see them in the picture there. Then now we have our brown, we have our black, we have our gray, we have our blue, we have our green and yellow. Once an electrician comes to your facility and he's drawing an estimate, you look out for these cables. Now, is he going to buy these cables to do the wiring? Let him buy those cables with this color coding to do the wiring. Every country has its standard. Some might be similar to others. There's a standard we all follow. There is an international standard, and out of that international standard, everyone can carve their own standard. And this is Ghana. Our standard is the electrical wire regulation, and we have to follow it. Right, next slide. The next. Thank you. We've come to the end of some little understanding or some small things or basic things we need to look out for when we engage someone to do wiring, and also what the electrical wire regulation is talking about. I guess this might be new information to some of us, and some of us have already heard it, but didn't get clarity on it. And I know this webinar has really enlightened us on what the electrical regulation is about and what we should look out for when anyone is about to do wiring for us. Thank you for your attention.
Thank you very much, Mr. Samuel Owusu. We are grateful for that informative lecture. In fact, most of us are living in old houses, so it's high time we review our wiring again to prevent any accident.
Yes.
Yes, so now we are at the question and answer session. If you want to ask a question, you can raise your hand up. And then I'm repeating again, the webinar has been recorded. We'll upload it on the Center's YouTube channel, which will be shared on the Center's Facebook page. So if you are interested in getting the recorded lecture after the presentation, you can check our Facebook page, and then you will have access to it to review or refer to. And those who want the lecture slides, Mr. Samuel has shared the slides with me. After the presentation, I will share it with those who are on our mailing list. If you still want to have it, you can share your email address on the chat box to be so that you are added to our mailing list. Yes, Ibrahim Rashad has his hand up, so I'm unmuting you to ask your question. Okay, you've unmuted yourself, so please go ahead with your question.
All right. Good afternoon, sir.
Yeah, good afternoon, Mr. Rashad.
Thank you very much for that presentation. Please, my question is, what is the effects on those who use copper wire to fix into their cutout where the fuse is supposed to be fixed? We normally term it as people doing U. They'll get some copper wire and then they'll bend it. And then they will now fix it to in the cutout where the fuse is supposed to be fixed. And we know that the cutout is supposed to be bent. It's not supposed to be bent when there's high current. And now that the fuse is not there and the person has used copper wire, what would be the effect on the wiring in the house? Thank you.
Thank you for that question. Mr. Samuel, can you respond to it? Hello. Hello. Hello, Mr. Samuel. I think he's off. Probably he will be joining us soon. But what I know is that the idea of the fuse is to protect you from such currents. So if most of those who do that, either they are doing illegal, they are bypassing the meter to connect directly into their house. And if you are bypassing the meter also has some protection. It means if there's any surge current, it comes directly into your house, and you are at the risk of causing damage to your equipment or even starting a fire in your home. So all these measures that we put in place is to protect your equipment and then save life. I hope you are answered, Mr. Rashad. Yes, whilst I'll try to respond to the questions whilst Mr. Samuel join us, and when he joins, I'll reiterate the questions to him if he can respond to them. Mr. Phil, please, you can unmute your mic and ask your question.
It has been a lovely day per the presentation. Hello?
Yeah, hello, I can hear you. Please go ahead.
Okay, so I just want to find out, per the presentation, he was talking about the other accessories, and we're talking about the star rating of devices. I just want to find out what goes into the production or manufacture of a device to determine its rating, star ratings.
Hello.
Thank you.
Yeah, hello.
Yes.
Can you hear? Did you hear me?
Yes, I heard you. I'm trying to reach Mr. Samuel.
Okay, thank you. I'm waiting.
Yes. Just a minute.
Engineer.
Yes.
Engineer Barrick, I'm back.
You are back. Okay. So please, did you get the question?
No, I didn't get the question. I just joined the game. I'm
Okay.
moving from devices from one devices to another.
Oh, it is well. Okay,
Yes,
Mr. Philip, can you ask your question again?
Okay, thanks again. Once again, thank you again. What I wanted to know per the presentation, he made mention of star ratings of some devices, electronic devices. And I want to know what goes into the production that determines the rating, the star ratings of those devices. I hope you heard me now.
Yes, hello.
Yes.
Okay.
Yeah, we heard you. So the star rating, like I was saying, it's determining how efficient the appliance is. So there are standards. There are certain standards which we've brought out, and the manufacturers have to meet that standard. So when we are saying a fridge is consuming this amount of watts, there's a standard to that. What are the materials used in making the fridge? All the standards are being used to check these things at the port. So our officers have this standard with them. Once the fridge comes from their manufacturers, they check and see whether this fridge meets the standards they are having. So these standards could be made available to you. We will make them available with time so that you can also know what when purchasing a fridge.
Okay, thank you for the response.
Okay, thank you too.
Yes, so Mr. Joseph, you can mute your mic and then ask your question.
Thank you. Good afternoon.
Yeah, good afternoon.
My question is still on the star rating.
Okay.
In your presentation, you said that the more the stars, the more efficient the device is. And in the market, you can find 3 stars, 2 stars, and sometimes even a single star. So as the institution in charge of the regulating of all this, why do you still continue to allow equipment with single stars to come into the system? Just as we are trying to weed out fake cables, why don't you also weed out equipment which have a single star rating or double star rating so that we can get efficient equipment in the system? Thank you.
Thank you.
Yes.
Mr. Samuel, can you take it?
Yes, I'll take that. This is a very important and valid claim, which the answer to this is, if we even wanted, or even if we like, we would have wished all the appliances had 5 stars. But you bear with me, like I was saying, there's a standard these appliances have to meet. And when we are coming out with standard, there is some tolerance. We give a range. We don't say it should be exactly this. You get it? When we are saying a fridge should consume exactly 50 watts, then we are saying no other fridge below 50 or even above the 50 should be accepted. But there's a range. So the one star is saying that it is efficient, but not as efficient as 3, not as efficient as 5. You get it? But it doesn't mean it is not efficient. It is within the range of efficiency, but just that it is 1 star.
Okay.
I hope it's good.
Yes, I hope, Mr. Joseph, your question has been answered. Engineer Kwame, please unmute your mic and ask your question.
Yes.
Hello, Engineer Kwame. Oh, Engineer Kwame is off. Then, hello. Eben should ask his question. Please lower your please unmute your mic and ask your question.
Okay, thank you very much, bosses. I have a couple of questions that I want to ask. So I want to know, with the RCD, the ratings, I learned it is 63 and 100, and I think 32 as well. So let's say a story building for like 3-story building. Which RCD is advisable for you to be able to give to that house to protect the whole house? That is one of my questions. I don't know whether you are getting my point. Hello?
Yeah, it's clear. It's clear.
Okay. Then I also want to ask, when can an MCCB be used in place of a cutout or an MCB, which is appropriate for, let's say, offices where people come to work every day? Let's say about a 3-story office or something. When you are the main power comes from the pole, maybe before to go to the distribution boards and all that. When it is given to an MCCB rated, let's say 200 amps, is it advisable, or you should use the MCB for something like that? And the head bus chamber, the head chamber that you spoke about, with let's say a 2-bedroom self-contained or something, is it compulsory that you have to prepare that head bus chamber, or like they do it, maybe they just get some 4-inch PVC pipe around the rod after they've added their charcoal and maybe sawdust and all that? I want clarification on these 3 things.
That's very great. So let's start with the first one. I've realized our engineer is enlightened in the electrical aspect, which is very good. So with the 3 stories, bear with me that when you have a 3-story facility, you are not sending a single phase supply to the facility. It could be a 3-phase. Hardly will you get a 3-story facility being supplied with a single phase facility. So our RCD descriptions are such that when you are sending a single phase to let's say the first floor, then you can employ your single phase RCD there, which you made mention, your 63 and your 32 milliamps. Then we have your 100 milliamps too for the 3-phase. But when it's entirely, you are using the RCD, which is not advisable, that you use the RCD for the whole facility. So that means if we are getting a misbalance or imbalance in the life and neutral in the down floor, it will have to affect the whole building. You get it? So for a single phase for the first floor, you can employ your single phase RCD there. You move to the second floor, employ another single phase RCD. Then the third one, you employ another single phase RCD. I hope you are getting my point.
Yeah, I get it. So assuming, let's say there's a 2-story building on each side. Let's say it's an apartment.
Okay.
2-story ground floor, 2-story at the opposite end. The same thing, 3. So in addition, to be like 6.
Exactly.
Per your explanation, are you saying that per every 2-bedroom apartment, an RCD should be given before the cables run to the consumer unit, or what? I don't know whether I get my point.
You are saying, okay, so you're having 2-story apartments, 3 of them.
3 of them.
Good. So if the wiring, you and I will agree that if you're having 3 separate stories such as this, you wouldn't give all of them just a consumer unit. You understand? So for each consumer unit to provide, there should be an RCD there. People even go as far as protecting some delicate circuits, such as the AC circuit, the water heater circuit, and also your cooker unit circuit with separate RCDs. That's how far people can go with the protection. But when in these cases here, due to, let's say, cost and all that, if you get one RCD for the whole facility, that's the first 2-story, then another RCD for the second 2-story, then the RCD for the next 2 stories. Once the electrical installation is not connected, I think you should find different RCDs for all of them.
Okay, so per this, I now understand you. So maybe for each. So now, which RCD ratings can be used for those? For which one is advisable? Is it the 32, the 63, or the 100? Because it may be like a 3-phase or something.
Exactly. So for the three phase, you are saying your 63 amps and your 100 milliamps. That's what you'll be using. So
Okay.
your 32 for the single phase.
Okay.
You get it?
I get it.
Yeah.
Yes.
Yeah.
Thank
So
you.
the second one, if you could review the second question.
Hello.
Hello.
Yeah.
Hello.
Please.
Yes.
So
This Patrick, please. This Engineer Patrick.
Okay, please. He's still responding to your question. When he's done, he will respond to your question.
okay.
No, I want to ask something.
Okay, you want to comment? Okay, please go ahead.
Yes, I want to comment. Yes. You see, in a storage building, we have the main distribution board that takes the bulk power from the VRA or let's say Netco supply. Then from the main board, then you pick your various you then pick the power to the various floors, to the what do you call it? Your various consumer units at various floors.
Okay.
Then at that point, that is where you now engage your your RCDs.
Okay.
One thing that the RCD you have to consider, you don't just go and buy RCD just in the name at 32 or 100 at like that. You consider your load.
Okay.
I get it.
I
For
get
instance, when you are going to use it to protect an air condition, you are supposed to know the rated current of the air condition, the minimum and the maximum. When I say the minimum and the maximum residual, there's always plus and minuses. I get it.
Yes.
So that you can size your RCD. Mr. Rashid, the one who does the presentation, this is something that I have encountered with some of the electricians. Sometimes I just laugh at them and I go. They just go and buy any RCD at all and come and put. There was a situation that they went and bought the wrong RCD and kept in the church. Always it will trip because they didn't size the RCD to meet the load of the church. In as much as the church didn't have problem, but because the sizing of the RCD wasn't met to meet the load of the church, they were always tripping. And I want to appeal that you should take it up from here and educate them on the sizing. Thank you.
Thank you for the response. So I must add, Mr. Edin, the sizing is key to determining how much. It's like you are going to buy a car to carry people, and you want to carry 20 people, and you buy a simple saloon car. You see, you have problem. But if you know the people you are going to carry, you will buy your car accordingly. Yes. So, Mr. Mohammed, I hope, Mr. Mohammed, you can unmute your mic and ask your question.
Please, he's not done with mine. No.
Hey.
I have like other two questions. I want clarifications. Please, kindly bear with me.
Okay.
Yeah. Can you review those two?
Again? Yes. So my next question was about the MCB and MCCB. So let's say you want to replace a cutout with maybe an MCB or an MCCB. Which one is advisable? Is it advisable to use the MCCB or the MCB?
Yeah. So the reason for the distribution utility employing the use of cutouts is for you not to just go and trip when there is an issue.
Okay.
You know, the MCB provides us with tripping mechanisms.
Yes.
That once it trips, you can readily use it. And you know the MCBs that are in the system, they come with low ratings.
Yes.
They come with low ratings, unless we are talking about our molded cage.
Yes.
That's the MCCB. Yes, the MCTBs. Those ones which have high ratings. So those ones can be used in place. If it's used in place, it will still function perfectly. But the reason being that those ones are quite expensive to buy. So some facilities they forgo the cutout, then go for the MCCBs rather than the cutout.
Okay. So by your explanation, as far as the person can afford an MCCB,
it can be used in place. It can be used in place of the fuse. Sorry, the cutout fuse. Yes. Yes. Hello.
Hello. I think that the line was breaking. So.
Yes. Can you hear me?
Yeah, I can hear you, but still...
Yes. So the molded cage can be used in place of the cutout fuse. Hello. Hello.
Yeah. Hello. Yes, you were audible.
Yes. So I don't know. Is it Engineer Mohammed? I don't know whether I get a clarification here.
Abin, yeah, I think it was clear.
Yeah.
Okay, Mr. Mohammed, we are running out of time. Please, can you ask your question? Can you unmute your mic and ask your question? Hey, yeah. Hello, Mr. Mohammed Nuruddin. Please, can you unmute your mic and ask your question? Hello. Okay, let's move to Mr. Rashad again. Oh, he's also gone off.
Hello.
Yeah, hello. Okay, Mr.
Hello.
Nuruddin. Yes, you are audible.
Yes, sir.
Please
Good
ask your
afternoon.
question. Good afternoon, sir.
Okay. Thank you for the lecture. All right. My question is, I've used all the standards, the cable, everything. And then I would like to know, even if you meet all the standards, for how long do you have to revisit your wiring? I mean, for how many years do you have to use it before you revisit it?
Okay, thank you.
You're welcome.
Yes. Hello. Oh, our presenter is off. I'm sure he's trying to join. Hello. Hello. Okay. Hello, Mr. Nuruddin. How long you reuse it depend on the usage? Okay. Hello, Engineer Patrick.
Yes, please.
Did you get the question? Hello.
Yes, I got it. Yes.
Can you hear me?
Yes,
I
we
got
can.
it. Yeah.
Okay.
Yes. So they are saying once the facility is done and the standard has been met, they are saying after 10 years, you would have to do inspection and testing again. Then after that 10 years, you do it 5 years till 30 years. Then after the 30 years, you should be looking at changing the wiring, but that will be based on another year or 2 years to 3 years inspection and testing again.
Okay.
You get it. The standard has been made. There's a range, but some cables wouldn't last till the 30 years, or some cables can last and would be weakened after the 30 years. So some inspectors, or when you go and do your inspection and you invite an inspector to do the inspection and testing after the 30 years, based on his findings compared to the previous years of inspection, they will then determine that, okay, this facility has to be rewired, or you have to do some adjustments to certain portions of the installation.
Okay.
So 10 years after installation, 5 years to 30 years, then now you do it 2 to 3 years.
Okay. Thank you.
So I want to add something on it.
Okay. Engineer Patrick.
Yes. Yeah. Why the need for testing? As you use power to you pass power through the cables. There are some instances it generates heat. When it generates heat, it affects the insulation. Then it breaks the resistance of the insulation of the cables gradually. Hence, when you don't take care to monitor the installation resistance to test to know, oh, is my installation still effective after 10 years? Eventually, it can result, the installation can break totally, and it will result into what do you call a fire outbreaks. Again, as my brother mentioned earlier on, current needs the shortest possible or the smallest possible resistance to flow. So as you are using the cables, the more it is being used, the resistance increases due to these heats that we've just mentioned and other factors that play in the your usage of the wiring. Then as the resistance increases, then as time goes on, it becomes difficult for what do you call it, for free flow of electric power to those cables. Hence, the result to heating, and it can also lead to what do you call it, electrical fires and sparks and all sort of those things. Then it informs us that the need and the very important what do you call it, need for us to always try and test our installation from time to time to know how it is performing. Thank you.
Thank you for the comment. Yes, I think we'll take the last 3 questions quickly and then we can end the webinar. So Engineer Joseph, please, can you unmute your mic and ask your question?
Good afternoon.
Good afternoon. Yeah, good afternoon.
I want to ask my question with regards to the earth inspection chamber. We are told that after burying your earth rod, you have to cover it with a particular material. I heard people say that charcoal is the best material. Others also say that palm kernel oil residue is also good. I want to find out which particular material you recommend for the inspection chamber after you have buried the earth rod. Which material will you recommend that we use to cover the earth rod, and why?
Okay. So, yes. So in my earlier submission, and as engineer, I think Patrick was also confirming that we are saying the soil has to be less resistive. So we'll have to do anything to make the soil less resistive. And you bear with me, even in the dry season or let's talk about the wet seasons now, where the weather is moist and the ground is wet. When you dig or when you create an earthing system in that season, you are likely to get a very good earth value because of how moist the ground is. That's made it less resistive. But when it comes to the dry season, now we have your soil acting as clay and sandy, very loose, creating a very high resistance. So even the rod can't even sit well in the ground. And the resistance now from the rod to the ground becomes very high. So these materials we are using, we've realized that their resistivity is very good with the soil and to the rod. So a combination of the charcoal and the palm kernel, it's very, very good. Using the palm kernel alone is equally okay. Using the charcoal is also okay. So far what we've seen is using charcoal, it should be in a powdered form. The palm kernel chaff too, or the palm kernel cake, when using that one too, you are using it in its finest form. And you are pounding it. You pound it to make it compact in the ground so that it sticks very well to the rod. It shouldn't be that loose to create that resistance. When the rod is very, very deep into this mixture I'm talking about, either the charcoal or the palm kernel or both with your water inclusive, let it dry, settle, and pound it and let it be compact. You get a very good earth resistance value. You know, the shortcomings of this earth resistance is you are just building the earth around where the earth rod is. But if we understand the mechanism of how an earthing system operates to go and even trip a breaker, you would realize that there are shortcomings because you can't treat the whole earth from the rod there to where the transformer is. You get when you are tracing fault, the fault has to move from the facility down to the ground, then move to the transformer's neutral, then comes back to the facility to trip a breaker. And if it happens that way and it's not having a very clear path to move, at that point in time, where your earth is buried, the resistance could be good because of these materials. But how about the
distributing side there, is their resistance good? But notwithstanding, it doesn't prevent us from improving our side. So using the charcoal and the palm kernel, they are equally good. They are equally good. We used to use sawdust, but lately we realized the sawdust with time it rusts the rod, which wouldn't be beneficial to the rod in a long time. So we keep advising people not to use the sawdust. Because this mahogany, when it gets to a point in time, it rusts the rod. It corrodes it rather. Okay. So using the charcoal and the palm kernel, they are equally good.
Okay, thank you for the response. Mr. Rashad.
Thank you. Thank you very much. I'm not an electrical engineer, but I'm a house owner. And what I have noticed is that with regards to the consumption in my house, there is a remarkable change when I apply the palm kernel residue or palm kernel cake. Indeed, I'm very grateful that I've joined this webinar and I've enlightened myself. I now see the reason why it was necessary for me to do that. Earlier on, when I did not use the cake, my consumption was very high. But immediately I used the cake, the consumption went down drastically.
Okay.
For this webinar, and I thank you.
Okay. Okay. Thank you for the comment. Yes, Mr. Rashad, please lower your, please unmute your mic and ask your question. Then we'll take, I think.
Thank you.
Yes.
Presentation. We should adopt full conduit wiring. And I want to know if you use this kind of wiring in the ceiling and there happens to be a bend in the set, won't there be difficult tracing where the bend is?
If I got it clear, that means, yes, maybe there is a break in the cable as a result of bend. Is that a question? Okay. So that is why.
Yes, please.
That is why we do testing. That's why we do testing. You get it. So once you are doing testing to a facility, you'll be able to pinpoint where there is a fault, and you trace that fault to that piping. I don't know whether you are getting it. We are doing tests circuit by circuit. So when you find that there's a fault in this circuit, that is where you start your tracing point. You'll be able to trace it to see that it's passing through this pipeline.
Okay, thank you. Then the last question, Engineer Kwame, please unmute your mic and ask.
All right, thank you very much. Good afternoon.
Good afternoon.
That tightening presentation. I have few concerns. One is about the certified electricians. Okay, I want to find out. I am an electrical engineer, but I am not certified with Energy Commission. If I do my own wiring in my house, everything following the regulations, I want to find out what happens to that. Would I be? Will the inspector accept to inspect it? That is one. Two, the presenter mentioned of color coding of cables. I have had experience with electricians some electricians before. The past we used to have red, yellow, blue, and then black and earth, where the black is the earth. That is in the past. But now you have brown, black, gray, blue, and the earth, where we have the blue to be earth. So when you go to the old system, when you go to a facility, you find out that some still have the old cables, and you give them the new cables to do installation. Surprisingly, some are unable to match the cable, how we should follow, especially with three-phase. I want to find out the certification training. Do Energy Commission train the electrician in these areas? I'm saying this because I've had an encounter with even ECG contractor where I had to pull out regulations for him to see before he accepted.
Hello. Oh, hello.
Them what they are supposed to be doing on the field. In as much as that, this is just like the classroom. You do your best as a teacher to teach everyone. And yet still, you have some people not adhering to that. This is where we put in place. So once you are able to conform to that, someone will check you. And if the person checks you 1, 2, 3, then you bear with me that you start doing the right thing. So with the color coding, it's something we are advocating. It's not on a silver platter to implement, just like the RCD, which now everyone is beginning to understand the use of RCDs and the importance of earthing systems, and also why the test needs to be carried out. That is the same thing this color coding is also passing through. You understand? People are used to the old system of color coding. And for facilities who already have the old color coding, when an alteration is being done, this is where the electrician has access to the facility. So we advise them, if you can't change, if there's nothing wrong with the old color coding cable, then you can employ the use of sleeves, these tapes. There are tapes which also come in the new color coding. Employ them close to the termination. So that if anyone comes and sees that, the person will be able to determine, okay, even though it's red, but it's matching the brown or has a brown taping to indicate that you know what the color coding is, and you've employed the new color coding in an addition. So you have to make that distinction that any red cable you see with a brown tape or a brown seal, it's also indicating that it's a life. Then for your green, the green are still being maintained, your green and yellow as your earth. Then your blue too for your black, that's the neutral, which is also handled with the tips and the sleeves. Then I think your first question was the wiring part. That's if you're an engineer, you know how to do electrical wiring. Okay, that's the same question. I'd like to throw this question back to all of us again, that if someone has been able to learn a skill of doing surgery, or has even gone to the medical school and is able to do a surgery on even an animal or even on a human being, and his or a relative happen to be sick and he has the tools to carry out that surgery, would it be advisable for him to do that, or he has to go to the hospital to get assistance? You get it? The answer will always be no. It doesn't matter, or it doesn't matter how good you are in the field. Once you are not certified to do that, here is the case. You shouldn't do it. You can have all your driving skills. Once you don't have a driving license, you are not supposed to pick up a vehicle and be driving in town. The police will have issues. So even though it's your own house, you are still saying once you be connected to the grid,
once you be connected to the distribution utilities grid, you have to go according to the regulation. The regulation is saying, at no point in time should anyone do wiring if the person is not certified by the Energy Commission. So you have to engage the services of a certified person. And glory be to God, since you are enlightened in the field, you can be a very good supervisor even before the inspectors come around, so that the person doesn't mess the place up for you. So, Engineer Kwame, that is it.
All right. Thank you.
You're welcome.
Okay, so thank you very much for the participation. I must acknowledge that we had people from diverse backgrounds, ranging from students to engineering professionals. Even the BAG of the Biogas Association of Ghana was with us. Some professors from University for Development Studies also joined us, and the head of the Korean Center was also part of us. And all those who have been able to hold the fort till this time, we are grateful. And if you've shared your email after this presentation, I will process the video and then upload it on our YouTube channel, and then send the link to all those who have submitted their emails for the slides. Thank you again. And then thank you to Mr. Samuel Owusu for that insightful presentation. We are grateful for the education you've given all of us. In fact, most of us are in homes that are over 10 years, so it's high time we review our home wiring system to prevent any fatal accidents. Thank you very much. And then after, I think, Mr. Samuel, do you have any closing remarks?
Yes, I have some few last words.
Okay.
Yes, it's very good, or it's nice we have such personnel on to join this meeting. And that means we'll be having some subordinates under them. And our examination, the electrical wiring examination, it runs twice in a year. And we'll be wishing, if anyone interested in electrical wiring or has learned the skill of electrical wiring, to prepare him or herself to come and take the exams, so that they won't be found wanting when they are doing wiring, which is not up to what the requirements of the law is saying. So this is just an appeal, and also just to put it at the back of our heads, that if we come into contact with people who pick up the electrical wiring courses and are interested in wiring, they can, after school, after apprenticeship, they can just come pick up our forms, which is readily available on our website, and they register for it. The engineer, I think we would make available to our contacts in the Tamale offices here. We have offices across the country in Takrady. For the time being, we have offices in Takrady, we have offices in Kumasi, and Tamale here, and also the head office in Accra. So I'll put out our contacts, and if any other information anyone needs, the person can just contact the Energy Commission and we'll be ready to assist you. And we have 3 books in the system, which I would also be glad if we can all get a copy. That's the regulation, the electrical wiring regulation, LI 2008. We can make some available in our offices, which you can come and purchase. That's for purchase because it's a law which is being sold at assembly price. And our guidelines, those guidelines are free. Our guidelines are free. So the offices I mentioned, you can just walk in and request for a guideline. We'll give you one. It has been presented and broken down to the latest degree, what the customer needs to do, what distribution utility needs to do, what electrician needs to do, how to identify electrician. Everything that requires the regulation is broken down into the guideline, made very easy for anyone to read and understand. So I'll thank you all for having time for us. I think the number we started with, we've been able to maintain it to some extent, which is very good. And our engineer, Mubarak, we also thank you for hosting us on the Energy Technology Center on this webinar. Thank you very much.
And thank you, Mr. Samuel Owusu, for your closing remarks. In fact, I must say that among all the government institutions I've been working with, Energy Commission is one of a kind. You guys have